We will now see how to calculate the variable importance in random forests. Here you have two examples of calculating the variable importance with random forest on California real estate data aimed at predicting the price of homes based on their characteristics and inhabitants. To obtain these values, we first train a random forest on the data and then apply two separate procedures, each of which computes a variable importance. Indeed, two importance measures are available in the random forest: the MDI, mean decrease in impurity, presented on the left, and the MDA, for mean decrease in accuracy, presented on the right. In each graph, the 8 input variables are presented and ordered according to the importance provided by the procedure, MDI or MDA. For both importance measures, the variable with the highest importance appears to be the median income of the inhabitants for the block under consideration, the smallest geographic unit for the dataset. Random forest and ensemble methods are often referred to as black boxes. Even if a tree is interpretable, the decision process leading to the prediction is well understood, the random forest is not, because it consists of several hundreds of trees. The variable importance is a simple indicator that allows us to understand which input variable the prediction depends on. Specifically, we are interested in the variables that are related to the actual output and not those that are related to the prediction of the algorithm. In our case, we are trying to answer the question, what variables does the price of housing depend on? Notice that the two importance measures, the MDI and MDA, provide two different rankings for the input variables. The importance of each variable differs depending on the indicator considered. For the MDA, the second variable is the latitude of the geographic area, while for the MDI, the second variable is the average occupancy rate of the home. Depending on the importance measure used, different results are obtained, leading to a different interpretation of the role of the input variables on the output. It is therefore important to understand the differences between these measures and how to use them appropriately. In what situation can variable importance be used? First of all, there is no single quantity that perfectly measures the importance of variables. It always depends on the use that will be made of it afterwards. It has no definition, no intrinsic meaning outside of a problem, and must always be chosen according to a precise task. Let's take a very simple example to illustrate this point. Suppose we have an input of dimension 10, thus containing 10 components, a continuous output y, and a model y equal x1. We also assume that the variable x1 is itself a function of the variables x2 through x10. Several motivations exist for using variable importances. The first, which may seem the most natural, is variable selection. In this framework, we would like to build a model with a low number of input variables that has a very good predictive performance. With this goal in mind, and in our example, we would like to obtain high importance for x1 and importances for x2 up to x10 that are very low. We could then use this importance measure as a criterion to select variables with fairly high importance, here x1, and remove the remaining variables from the model, here x2 up to x10. We may also want to identify the relationships between all the input variables and the output. In particular, this is useful for identifying variables not related to the output and for a better understanding of the model. This emphasis can be useful to domain experts in building new models or testing new hypotheses. In our example, the variable x2 is related to the variable x1, which is itself related to the output. If we wanted to identify all the variables related to the output, we would like to obtain an importance that is non-zero for all variables from x1 to x10. The measures of importance that we would like to obtain therefore differ depending on the task at hand, either selecting a predictive model containing a small number of variables or identifying all the links between the input variables and the output. It is essential to remember that there is not a single variable importance measure, but as many measures as there are tasks that can be considered. Two importance measures can be calculated for random forest, the MDI for mean decrease in impurity and the MDA for mean decrease in accuracy. The MDI is a measure proposed by Leo Brinman, the creator of random forest, in 2002. It is a measure that is specific to decision tree methods and therefore cannot be used to calculate the importance of other machine learning algorithms. The MDI of a given variable is the average of the impurity decreases for all cuts in the forest, each cut of each tree, made according to the variable in question. Intuitively, if the variable has an impact on prediction, then cuts made according to that variable should be predictive, i.e. associated with a high impurity decrease and thus a high MDI. The other importance measure, the MDA, also called importance by permutation, was invented by Leo Breiman in 2001 for forests and is not specific to decision tree methods. It can be used for all supervised learning algorithms. The MDA is based on a permutation of the values of the variable considered in the test set. The MDA is equal to the difference between the predictive performance of the forest on the initial test set and on the permuted test set. Intuitively, if the variable has an impact on the prediction, permuting its values should decrease the predictive performance of the forest, which should lead to a high MDA. We will now detail the construction of these two indicators.